Okay, simplifying algebraic expressions. So first we're going to start with a little pre-algebra. We're going to go back to our exponents. If you haven't watched the video on exponents in PEMDAS, you need to watch that video first. So let's say we have a number 7 with an exponent 3. This number right here is called the base. Now it doesn't have to be a number, it can be a letter. So you had a variable a variable x with an exponent 3. That x is also called the base. You need to know that term because of what I'm about to tell you. If you have two numbers, or two terms I should say, that have the same base but have different exponents, and you're multiplying, you can combine them. Now, don't just punch this in on the calculator because that's going to give you like a huge number. So let's just see what that would do. So it's going to give you the number, what is that? 1,953,125. That is usually not what they want on the test. They want to know that you know how to combine exponents with the same base. So the worksheet I'm going to give you is just going to want you to learn how to combine exponents. So like I said, they have the same base, 5 and 5. Just rewrite the base. Now when you're multiplying, what's happening is this exponent is getting added to this exponent. Do not multiply the exponents. There are cases where you multiply exponents, but those involve parentheses, and these don't. So it's just 9 as your new exponent. That's it. That's all they want you to do. Now sometimes you're going to have basically the same question, except you're going to have it with variables. That makes it algebra. So same problem, different base. You work it exactly the same way. So you would just bring down the x because that's your base. And you would add your 4 and your 5, and you get 9. Now here's what's actually going on. So this right here is 5 to the 4th, which means you're multiplying 5 4 times. This means you're multiplying 5 5 times, but you're also multiplying these two, so that's your multiplication for the problem. So what you end up with is you end up with 4 5s here from that, and 5 5s here from that. So if you count all those together, you have 9. That's the exact same thing as 5 to the 9th. Now it would be the same thing if I wrote the x's out. I would have 4 x's, 5 x's, so you end up with 9 x's, and that's where you're getting x to the 9th. Now that's multiplying. Dividing is the opposite. So let's say we had 8 to the 5th divided by 8 to the 3rd. So when we multiply, we add our exponents together. When we divide, we actually subtract our exponents. Like I said, it's just the opposite. So if you take 5 away from 3, you end up with 2. So your answer would just be 8 squared. So I'll explain what's going on there. So if you had 8 to the 5th on top, you're multiplying 8 5s. And if you had 8 to the third on the bottom, it's 3/8. So if you know your fraction lesson, you know anything over itself is equal to 1. Well, that's equal to 1, that's equal to 1, that's equal to 1. So 1 times 1 times 1 times 8 times 8 is really just 8 times 8, because multiplying times multiple ones doesn't do anything, so they just go away. So you're left with 2 8s on top, which is 8 squared. Now that if you have a higher exponent on top than you do on bottom, that's what happens. If you have a higher exponent on the bottom, the opposite happens. So if you have x to the 5th over x to the 8th, what would happen is 5 of these x's would cancel out with 5 of these x's, and you'd be left with x to the third on the bottom. Now, a lot of people just want to write x to the third, but that's not correct because you're on the bottom. In this case, you actually need those ones. So remember when we canceled each of these out, it made 3 1s. Well, when you cancel these 5 x's out, you're making 5 1s. So 1 times 1 times 1 times 1 times 1, which is 1. So when your larger exponent is on the bottom, you have to keep that exponent on the bottom and then keep a 1 on the top, because all your x's disappeared on top. It doesn't just turn into x cubed. That would be a totally different problem. One more thing. The reason why this is turning into 1 is because any number or variable with an exponent of 0 ends up being 1, and you'll need to know that for this worksheet. So what's happening is you're subtracting 5 from that, and you're subtracting 5 from that, and that ends up being 0, and that ends up being 3. So x to the 0 is 1. And that goes for anything. You can have 7 to the 0, and that's still equal to 1. And that's not degrees, that's to the 0 power. So this moves us on to mixing numbers and letters together. Let's say you had this expression. So you would start with the numbers. 28 divided by 4 is 7. And then you would do your simplifying with your division. So since we're dividing, we're subtracting. So our larger exponent is at the top, so we're going to be okay. 4 minus 2 is 2. So we're left with 2. You just bring your base down with your squared exponent. We can do one where the numbers on the bottom are bigger than the numbers on top. Let's say you had 5 x to the third over 25 x. This is something I didn't talk about earlier. When you don't have an exponent here, what you actually have is an invisible 1. They're not going to write 1 because 1 doesn't do anything, because x to the first power just means x. So that's a waste of space. But you need to know that that's there for subtracting purposes. So 5 over 25, if you remember from the calculator lesson, you can just punch that in on the calculator if you've got it. So fraction key, 5, down, 25, enter. And it gives you 1/5 as an answer. So you can start by just putting 1/5. We've got 3 x's on the top, 1 x on the bottom. 3 minus 1 is 2. And since the larger exponent was at the top, then the x stays at the top with the 2. Now, when you're left with a variable on top, you don't need this 1. I just wrote that 1 down for a placeholder. So that goes away. So really, you can line those up if you want. Really what you've got is x squared over 5 as an answer. Now you can have any mixture of what we just went over. Let's say we had 35 on top with x squared, and we had 5 on the bottom with x to the 6th. So you would start by doing your numbers. 35 over 5 is 7. But in this case, your larger exponent is at the bottom. So you subtract 2 from that, and you end up with 4. But that 4 has to stay at the bottom with the x at the bottom. The one on top goes away. So you end up with x to the 4th on the bottom. So wherever your largest exponent is, that's where your variable stays. The larger exponent was on the bottom, so it stayed at the bottom. Now you can do multiple numbers and multiple answers. Variables. Let's say we had 36 x to the 5th y squared over 12 x y to the 4th. So you start with the numbers, 36 over 12. You can punch that on your calculator. You'll get 3. X to the 5th over x to the 1st. So 5 minus 1 is going to be 4. And since our larger exponent was on top, this stays on top. The y, the larger exponent's at the bottom. So 4 minus 2 is going to be 2. But it's got to be on the bottom of the fraction. That's it. All you're doing is simplifying these. You're not solving them. Now that's multiplying and dividing. That should be as difficult as you need to know for the GED. When you're adding and subtracting, it's a whole different set of rules. So just like when you're adding and subtracting fractions, you have to go by a different set of rules when you're multiplying and dividing fractions. You need 2 rules. So these rules determine what's called like terms. And that is a vocabulary word that you need to know for the test. So like terms are 2 terms that you can add or subtract together. The 2 rules that determine if it's a like term: same variables. Not just some of the variables, all the variables have to be the same. Number 2, same exponents. For example, say we had 10x squared plus 3x squared. So both of them have x, so that matches number 1. Both of them have squared, so that matches number 2. So therefore they're like terms. If they're like terms, you can continue to add. So you just add just like you're adding numbers. So 10 plus 3 is 13. The base comes down untouched. It's different than multiplying. I see a lot of people want to add these together and have x to the 4th. That only happens when you are multiplying variables. You never change the exponent when you're adding and subtracting variables. Let's say you had 13y squared plus 4y. Well, it goes by rule number 1, same variables. You got a y and a y. But when you get to number 2, same exponents. This has a squared and this doesn't. So this can't go any further. So this expression is done. It's in the simplest form possible. So let's say you had this long expression: 5x squared y plus 3x squared plus 4y. Well, it seems like everything's the same. You got x squared y here, you got x squared here, you got y here. So it seems like people could just add 5 plus 3 plus 4 and get 12 and then put x squared y and it would be fine. But you can't. That's got x squared y. This doesn't have a y. So this is not a like term to that. This has x squared and y. This has just y. So this doesn't have x squared. So that's not a like term to that. And of course, these aren't like terms because that's an x and that's a y. So this expression is as far as you can go. Say you ended up with something like this. So you just start one term at a time. We've got x squared. Are there any more x squareds? No. Bring it down. You got positive 4x. Are there any other x's? Yes. Negative 6x. So this is where you have to know your integer rules, or you need to use a calculator. So once you realize those are like terms with the x, you don't enter the x into the calculator, you just enter the numbers. So positive 4 minus 6 is going to give you negative 2. Because they're different signs, you subtract them and keep the sign a little larger. But don't forget your x. That comes down unchanged. Then you got positive 3 and positive 10. Well, they don't have any variables or exponents, so you can just combine them. People get confused about that sometimes. Those are just regular numbers. So 3 and 10 ends up being 13. So that's it. That light's got a bad glare. 10x squared minus 2x plus 13. I have a paper shortage. Here it is. Okay, so you could be doing multiplying and adding and subtracting all in the same problem. Let's go over multiplying with parentheses first. So let's say you had a number touching a parentheses with a term with a variable and a term without a variable. Well, PEMDAS tells you to do parentheses first, but you know from what you just learned that this can't be added to this because this has an x and this doesn't. It doesn't just become 7x. So there's a rule that lets you break the parentheses rule, and it's called distributive. So that means that you distribute the number that's in front of the parentheses to all the numbers inside the parentheses by multiplying, because anytime a number is touching a parentheses, it means multiply. So the 5 gets multiplied by the 3x. Now remember, those rules for same variable, same exponent, they only apply to adding and subtracting. Remember, when we're multiplying, there's no rule like that. So since this doesn't have an x, you can still multiply by this that does have an x. So you just multiply the front numbers. You get 15, and then since that has an x, you bring that down. Then the 5 gets multiplied by the 4, positive 4. So you end up with positive 20. And that's it. That's as far as you can go on that, because that's got an x and that doesn't. You're done. So what I was going to say is you can have all this combined into one big problem. So that, for instance, well, you would follow your PEMDAS, so you got to get rid of these parentheses before you do anything else. You've got to do your distributive property just like we did over here, because there's a 6 touching your parentheses. So 6 gets multiplied by 3x, 18x. 6 gets multiplied by negative 2. Remember the sign in front, even though that's subtraction, you treat it like it's a negative when you're multiplying or dividing. So 6 times negative 2 is going to be negative 12. Don't put plus negative 12. Don't put minus negative 12. Just put minus 12. It just changes back into a minus sign. Bring down everything that we didn't multiply. Now you can start combining your like terms. So now that you're done with all your multiplication and division, So 12x is a like term of 18x. Add those together. 30x. Negative 12 is a like term with 20. You can flip those around. 20 minus 12 is positive 8. And that would be done. Do one more of those. Now sometimes you just get a minus and then a parentheses like that. I'm going to show you how to do that. So it looks like you can just drop the parentheses and then just subtract the 4x from 8x, but you can't, because the reason why those are in parentheses is because that minus has to get applied to everything. Now what you have here is you basically have another invisible 1. So anytime there's a minus touching a parentheses, what you've got to do is you've got to treat it like it's negative 1. And that negative 1 has to be distributed to both of those numbers in there. So negative 1 times positive 4 ends up being negative 4x. Negative 1 times positive 2 ends up being negative 2. So basically all it does is change the signs of everything inside. So if you want to remember it that way, that's fine. Or if you want to do your distributive property, that's fine. Bring down everything that you didn't multiply, then combine your like terms. So 8x minus 4x is just 4x. Negative 2 plus 6, so 6 minus 2 is positive 4. And that's as far as you can go with that one. Now to the worksheets. This first worksheet just wants you to know that you know how to combine exponents. Since we have the same base, we bring the base down. Since we're multiplying, that means we add our exponents together. So number 1 would just be 6 to the 15th. That's all they want you to do. This one's dividing. So since our larger exponent is at the top, we just simply subtract, bring our base, and then 6 minus 2 is 4. So that one's just going to be 4 to the 4th, and it's done. Remember, if you get an exponent of 0, it just turns into 1. So this is when it gets into the algebra. Now, we didn't do one like this, so I'm glad that came up. You would simplify 70 over 60. If you punch that in the calculator, it comes up as 7 over 6. Just leave it as a fraction. Don't turn it into decimal. If you have the same number of exponents on the top that you do on the bottom, this is y squared and this is y squared, if you can't see that, then they just disappear, because you end up with y to the 0, and y to the 0 is 1, and 1 times anything is itself. So anytime you end up with the same exponent, they just go away. So the answer number 1 doesn't have any variables. It's just 7 over 6. That's okay. Just because you start with variables doesn't mean you have to end with variables. Let's do one more. 72 over 45. I think 9 is the largest thing, but there could be something else. So 9 will go into that 8 times. 9 will go into that 5 times. So that is correct. We've got 5 x's on the top, 3 x's on the bottom. So our x stays at the top. 5 minus 3 is 2. That's it. 8x squared over 5. That's the answer. This one is just adding and subtracting. So you find your like terms. We got 3w and 9w, but remember this is minus 9w. So when you have a negative 9 and a positive 3, you can punch that in if you want. 3 minus 9 is negative 6. So you actually have negative 6w. Now you can punch it in the other way. It doesn't affect anything. Negative 9 plus 3 is still going to give you the same answer. 7 was the only whole number, so we just bring that over. Positive 7. And you're done. This one gets a little bit more complicated. So this is where you start adding, subtracting, and multiplying. I didn't put any dividing in here yet. It's just multiplying. So we're going to skip all these beginning ones because that's just like that first page that we went over. There is one thing that I forgot to tell you. So look at number 3, 7x minus x. If there's not a number in front of your variable, by the way, the number in front of your variable is called a coefficient. If there's no coefficient in front of your variable, always add a 1 because there's an invisible 1 there. So if you did 7x minus x, it's just 7, that would be wrong. If you did 7x minus x, it's just 7x, then that would also be wrong. It's actually 7x minus 1x, which ends up being 6x. Now down here, all the way down to number 16. So we've got a number touching parentheses, so we multiply -2 times 7, -14. -2 times -n, so a negative times a negative makes it positive. We just put the 2 in front of the n, and then we bring down our +4. Then we combine our +4 with our -14. Punch that in on the calculator, you end up with -10 plus 2n. Now, this is a question people ask me all the time. Does the order matter? Technically, no, this is correct. But there is math etiquette that most worksheets and most tests go by. They usually put the variable first. So what you need to know is that this is the same as this. So just because you get an answer like this, it doesn't mean it's wrong. It just means it's not in the order that they want you to put it in. So just know that you can just take this and move it into the front and have it just be 2n minus 10. Okay, so this is one that I was telling you about. It just has a negative in front of the parentheses. So put a 1 there to remind yourself to multiply -1. So -1 times 1 is just going to be -1. -1 times -6p. Negative times a negative makes it positive 6p. Bring down your -4p. Now you combine like terms. 6p minus 4p is going to be 2p. And then -1 is the only whole number. So it just comes over 2p minus 1. And that's it. So you've got answers to all these worksheets on the back. Try them yourself at the end of the video.